the same question as Arten, but we are using a different model. So I will give another results in another method in machine learning of AGN selection. Okay. This is my outline. I will give you the target we are going to achieve, and I will give you a brief introduction of our model. And our model is called deep learning. And I will show you how we train this AI and how it gives us the results. So our target is, today we have data of photometric for objects, and we have the redshift for objects. And we want to know, based on these data, we want to do a classification problem to classify this is a star-formed galaxy or an AGN. And this is an important problem. So we construct an AI system to achieve this. So what we are going to do is to achieve this system. Okay. And we need to do the AGN separation is because AGN helps us understand the evolution of galaxies. But the obvious band of AGNs is very likely to be obscured by dust. So we could only use infrared data to do classifications. But this is not easy, so we need an AI system to achieve this. Well, we have more than 18 bands for objects. So for humans, it's too hard for us to distinguish this. And AI could output the classification results in a very short time to deal with a very big amount of galaxies. And the most important part is the technology of AI could have a more correct classification accuracy than traditional SCD feeding. Then now I'm going to give you brief introductions of our models. And this model in deep learning, we call it multi-layer perceptions. It has many layers inside. So this model is based on a training of the big data sets. And we are going to train our model with a spectroscopic redshift and a spectroscopic labeled samples. Which means we previously used a spectroscopic data to pre-classify the samples. And we take these samples as our training data to train our systems. So this is a supervised learning. So today while we are training, we input the photometric data and spectroscopic redshifts, and let it go through our AI systems, the baby AI systems, and let it do the classifications. But apparently, this is impossible for AI to achieve the correct results at the beginning. So we need a process of training. How we do this is the system inside. You can see we have many cells here, and this is fully connected between them. But we input our photometric data in the first layers. So we vectorize this, and if you look closer to these systems, all of these lines means the weightings. Well, we have data here and data here. We multiply these weightings to add up on the next layer cells, and we do all of this for all of the cells. And in this instance, all the cells is activated by activation like this. This function is called redo function. Why we use this is because this system is based on simulation of human brain. And exactly based on our model research, human neural cells exactly act like this. So eventually, it tells us not a correct result of AGNs and star-formed galaxies. So we use these results to compare with the spectroscopic sample results. So we can calculate those and use these loss to feed back all the weightings inside. So we input here and let it go through all the weightings and let it output and compare with spectroscopic data and use these two results to feed back all the weightings and go through this again and feedback and go through the feedback for 1,000 times. So this is our result. Well, this is the rate of errors, and you can see as the training process, the error decreases. So this AI is actually learning. And you can see two lines here. The above line is in the test set, and the blue line is in the training set. Well, they are divided into 1,800 and 200. Well, the training is only based on the training set, not on the test set. And this orange line is based on the test set. So in this line, it's actually how this AI performs when it faces the real-world condition. You can see eventually after this error rate is converged, it reached to accuracy to about 12%. And it has a corresponding AGN recovery rate up to 71%. This picture is in the test set. So the orange line and in this picture is how this AI performs while it faces an unknown object. So eventually, how we use this AI is we have photometric data in the beginning and let it go through ACD fitting to let it have the photometric redshifts. And as well as photometric data, we input this, as well as photometric redshifts. We go through the AI system, we just construct and let it output the exactly correct results of AGN classification. So this is our conclusions. And the most important thing is, by this result, we could achieve a 23% higher accuracy to classify the AGNs and star-forming galaxies. So this is all my results. Thank you very much.
Thank you very much. And questions?
I know you haven't, but it would be very interesting for you to compare your list of new AGN that you found, which we're going to get Demo Spectra for, with the list that Artem has found. See how many of them overlap, how many of them are different, why they are different.
Next. Yes.
How many hidden layers which are used? Hidden layers. Two hidden layers.
Well, I have 7 hidden layers, and in each hidden, I have different numbers of neurons. Well, about 1,000 per layer, and totally 7 layers.
And how did you choose this number of layers?
How do I choose the number of these layers? All we can do is to try. So I try many times to let it achieve the best results. Because currently we have no theory to tell us how to choose these parameters.
So you choose different numbers and you decided that this number is optimal.
Yes.
More questions?
So Matt, I think he hasn't tried. He just tried it on a training set.
But you're now ready to do it on actual data, yeah?
Yeah, yes, that's what you need to do next time. So this sample, you already know the answer.
It looks like it works. Yeah.
This was the self-test.
So the next you can try it for the whole sample, and then compare with examples.
Right.
For Tina, so.
You had at least a 71% recovery rate.
Yes, yes.
Yes.
For the last point, when you compare to the ACD fitting, was it it's the same sample and the same data, or is it different?
I think there are not.
Well, you can check data or
Well,
if they are not the same, it's difficult to compare.
oh, how to say this? While we are testing the AGN recovery rates, they are not based on the same samples. But when we are making our method, try to control our method to do a computations, they are based on the same model of data.